Okay, let's just get the microphone in the right place. Hello, and welcome to another episode of Reasonable Coding. Today, we're going to talk a little bit about a language called Pony. This is episode number 22. I think I lost the first 3 or 4. So if you go into YouTube, you may not find them. But to give you an idea of what we're going to be looking at today, Pony is an actor-based language that has a number of very interesting qualities. It's memory safe, it requires no runtime, it's highly dynamic and concurrent, yet type safe. We will follow the official tutorial, right, and try to get a feel of why is this such a good tool for writing safe concurrent programs. Before we get started, if you already know that you won't be able to stay for the next 3 hours, then that's fine, don't worry. All of the live stream will be available in YouTube under the Reasonable Coding channel. You'll be able to come here and take a look at the playlists and all the videos that we had before, but also, of course, this one. If you do subscribe, you'll get a notification whenever a new video is posted, so you'll be able to just watch it, later on today or tomorrow or across a few days. And I think that this one is going to fall under the Exploring Concepts playlist. But let's get started. All right, this is the Pony website. It's quite modest, it just has the one color that they would choose to be the color for the brand, and they just say Pony on top with a few links to Twitter and GitHub. And then sort of they have the quick links for you to move around fast. Pony is an open source, object-oriented, actor model, capability secure, high-performance programming language, and that is quite a promise to live up to. It's not only open source and object-oriented, which are perhaps more common across languages, but it's also an actor model language, which makes you wonder how is it that the object orientation is going to play along with the concurrency aspects of actors, and essentially most importantly, the behavioral aspects of actors, right? How is it that an actor will be different from an object that belongs to a particular class? And is there any connection there? I don't know yet. We'll find out. Capability secure is something that I am not familiar with. I don't really know what it means when it says capabilities, but I expect it to essentially make strong guarantees about some behavior, either about the actors or about the objects, in a way that if you specify that behavior, it cannot be contradicted, or that you will have hopefully a mathematical proof that something will behave as you expect it to. And of course, high performance is the cherry on top of the sundae of awesome that this language seems to be. So I'm really excited to give it a shot. First, I'm just gonna drop by GitHub so you have a look at what they're like right now. Pony C seems to be built in C++. It has a lot of forks. It seems to have fairly good activity. So this is definitely a language that's currently being developed. They have a dependency managed, Pony stable. Interesting. I wonder if they have trouble saying stable, meaning both the place where horses are, but also the status of a dependency. Oh, this dependency is stable. It's also in the stable, but they have RFCs. Oh, brilliant. I'd love to quickly have a look at this. They might use something like, this looks a lot like the Rust RFC process. You fork, you put it in text, and then you have a bunch of RFCs in here. This looks really cool. Ponylang. I wonder if they have a specification for their library, for their compiler. That might be a little bit too much. But anyways, if you go into Pony C, we'll see what it has inside. There's CI pipelining, there's a code of conduct, there's a shit ton of people that contributed. This is really nice. Backers, okay, so they're actually getting money to be able to work on this, which is brilliant. I think this is proof that you can build open source software for a living. Editor support seems to be pretty interesting. Space VM, okay, Pwn line installation. You can also just use Docker. I wonder if we can brew this. So I think Pony C would be the what we would like to brew. So let's just give this a shot, Pony C. I'll leave it there for a second. Okay. Fairly good activity, a healthy number of contributors, BS2 clause, good licensing. Looks good to me. So let's take a look at the playground for a little bit. Oops. And then we'll go through the tutorial. So we can compile this into ASM, but also to LLVM intermediate representation. Quite a bunch of... Okay, yeah, this might have a runtime in here. I'm not sure. But this is an actor. I do not know what these are. If these are methods, then what is the overlap between actors and classes? If these are messages the actor responds to. Okay. Oh, okay. So this is actually running this somewhere else, not in the browser. Nice touch. Cool. I don't know enough of the language to be able to play around with it, so we might as well just jump ahead into the tutorial. But before I do that, I'm gonna make sure I can read comments and stuff on my phone. How? All right. Good. Pony tutorial. Welcome to the Pony tutorial. If you're reading this, your chances are you want to learn Pony. That's great. We're going to make that happen. Good. I like the tone. Some experience programming already. Doesn't matter the language. Or camel. I like that. As long as you've written some code before, you should be fine. So Pony is an object-oriented actor model capability secure programming language. It's object-oriented because it has classes and objects. It's actor model because it has actors. Yay, Erlang. This behave like objects, but they also can execute code asynchronously. Actors make Pony awesome. I wonder if there is any overlap in them. Like, why would you... I reckon that parts of your code would require you to be synchronous, or you would want to make them synchronous to ensure that they are synchronous, and then you can fall back to objects and classes. But everything else that you want to be concurrent, you can use actors for. Okay, we'll see how that pans out. We say that Pony is capability secure. It means a few things. It's type safe, really. There's a mathematical proof of type safety. We'll open this inside. It's memory safe. I'd say this comes with type safe, but still interesting. There are no dangling pointers, no buffer overruns. The language doesn't even have the concept of null. No runtime exceptions, thank you so much. Data race free. No locks or atomic operations on anything like that. Instead, the type system can ensure at compile time that your concurrent program can never have data races. Well, right. This looks really good. Right. Oh, I mean, okay. I would say from the get-go that if actors execute asynchronously, then you can definitely have data races, but they will be a different kind of data races. And you can definitely have deadlocks, but this will be essentially based on how you are processing the messages that actors are sending to each other, right? If two actors send a message to each other concurrently, and then they require a response back, then they both might enter a state where the other is not answering because he's awaiting for the message. Erlang solves this by having timeouts on the receive clauses. So you can say, I'm going to receive a message, but after n seconds, if nothing happens, then either consume a new message or, blow up. So we'll see how they handle this thing. We'll talk more about capability secure, including both object capabilities and reference capabilities later. The pony philosophy: get stuff done. In the spirit of Richard Gabriel, the pony philosophy is neither the right thing nor worse is better, right? It is get stuff done. Incorrectness is simply not allowed. It's pointless to try to get stuff done if you can't guarantee the result is correct. Performance: runtime speed is more important than everything except correctness. Okay, so first make sure that everything is correct. Then make it as fast as you can, as long as you don't compromise correctness. The faster the program can get stuff done, the better. This is more important than anything except a correct result. Simplicity can be sacrificed for performance. It is more important for the interface to be simple than the implementation. The faster the programmer can get stuff done, the better. It's okay to make things a bit harder on the programmer to improve performance, but it's important to make things easier on the programmer than it is to make things easier on the language and runtime. Okay, I like it. So what I would be using will be easier than whatever the implementing team is working with. Consistency can be sacrificed for simplicity or performance. Don't let excessive consistency get in the way of getting stuff done. Interesting point, like really interesting. I all the time I see and hear people and teams saying that they want to be consistent, but sometimes being consistent with the whole of a code base that keeps growing in every slightly different directions is precisely the thing that gets in the way of doing something. You all of a sudden want to make sure that the pattern is applied in the exact same way across the whole code base. Because of doing that, you don't get what you need to do done. Which of course, if what you need to get done is getting the consistency in there, then it's fine. But you're going meta on the process. Completeness: it's nice to cover as many things as possible, but completeness can be sacrificed for anything else. Right. Very interesting. Guiding principles. Language must be trivial to parse for both humans and computers. No loadable code. Everything is known to the compiler. Yay. Fully type safe. There's no trust me, I know what I'm doing. Fully memory safe. No crashes. A program that compiles should never crash. Sensible errors. Interesting. Inherent build system, no separate application required to configure or build. Aim to reduce common programming bugs through the use of restrictive syntax. Provide a single and clear way to do things rather than catering for every programmer preferred prejudices. Make upgrades clean. Do not try to merge new features with the ones they're replacing. If something is broken, remove it and replace it in one go. Where possible, provide rewrite utilities to upgrade source between language versions. Good. Right. Reasonable build time. Okay. Again, don't compromise performance nor correctness. Allow the programmer to omit some things from the code. It's fine, but fully specifying should always be allowed. No ambiguity. The programmer should never have to guess what the compiler will do, or vice versa. Document required complexity. Not all language features have to be trivial to understand, but complex features must have full explanations in the docs to be allowed in the language. All I'm reading is I like. I'm liking all I'm reading. Fully defined semantics. The semantics of a language features must be available in the standard language documentation. It's not acceptable to leave behavior undefined or implementation dependent. Standard libraries should be implemented in Pony. Interoperability must be interoperable with other languages. This may require shim layer if non-primitive types are used. Avoid library pain. Efficient hardware access must be available, but this does not have to pervade the whole language. And if I remember, pervade means to go through every layer, spread through and perceived in every part of. Okay. Avoid library pain. Use of third-party Pony libraries should be as easy as possible with no surprises. A friend just told me there's a .actor TLD domain, which I find amazing. Okay. More help. There's a Slack community that we can look into. Mailing list. I guess I could go into the mailing list. Cool. So let's get started. Right. We might read some of this sometime soon. Oh, this is adorable. Ponylang. Join this group. Cool. I'll just confirm that on my phone. Don't want you all looking at my email. Confirm account. Boom, 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 boom. Cool. So overview. No. There you go. This sounds about what we want to do. We want to get things installed and try something out. Cool. All right, so what you'll need, and I guess we can take a look at some of the other tutorials first. This will give us a rough understanding of what we're getting into. 1 second. And then we can dig into the type system, the traits, those actors, classes, and primitives, expressions. I think I would like to go into the types first and then glance over expressions. Partial application. And go straight into capabilities. Really learn what this is about, right? And hopefully we'll get out of here in a few hours with a good idea of what Pony is capable of, what is good for, what it isn't good for. So let's get started. What do you need? You need a text editor and the Pony C compiler. If installing this thing worked, then I should have both. Boom. This looks about right. So let's make a repo for this and let's call it horsing around. And inside this repo, we'll write some of the code and we'll compile it on the right-hand side. I'll make this a little bigger, the font size. By the way, I'm listening to a playlist that's fully collaborative on Spotify, and it's called Reasonable Coding. So if you want to throw some music in here so I can listen while the live stream goes on, then feel free to do so. I'll just copy the playlist link on Twitch. I think it'll be fun. It could be something that you're listening to or something that you like or whatever. So pasting this in there. Boom. Cool. Going back to the tutorial. We can get this installed. The syntax for Pony. So if I do bundle RC, cool. So now I should be able to use the syntax, which is great. Can close this, and there we go. Compiling our program. All right. Hello world, your first Pony program. So let's make a main Pony. Main Pony. And in here we will have an actor, which is called main. And this seems to use new. I don't know why, but new, create, and there's a variable m that's of type environment. And the body says environment dot out dot print. What? And there's no semicolons. All right. So now we can do Pony C and then main Pony, and I expect that to build them. Whoa. Interesting. Oh, I just need to call Pony C. That's quite the output. What did it do? Alright, so it builds all of the built-in packages. Now it builds the whole of the horsing around folder. Generating reachability. We write down the horsing around.o file and then the binary. And that's 122 kilobytes. Yikes. I mean, naturally, the size in here will be mostly for the actor runtime, I presume. And that will amortize as you have more actors, right? And then you run the program. That's just what you did. Perfect. The next one will explain how it works. All right. So actor main is a type declaration, which means we define an actor. Okay. So actors can have asynchronous methods called behaviors, whereas classes maybe not. We'll talk more about it later. A Pony program has to have a main actor. Gotcha, I hear you. Okay, new create environment is the constructor. The keyword new means it's a function that creates a new instance of the type. In this case, it creates a new main. Okay, so constructors are named in Pony, which is not common in other languages that I'm aware of. That means there can be more than one way to construct an instance of type. Well, I guess, yeah. In Java, for example, you recur to like the static factory pattern to be able to. I can't believe I'm saying that in this podcast, but live stream. but you would use that to use the same underlying constructor to create different versions of the same class. So we create just one called create, one constructor. The parameters of function come next. In this case, our constructor has a single parameter, which is emb of type emb. It turns out the main actor has to have a constructor called create that takes a single parameter of type env. Okay. So I guess this is property and method access. Impounding a dot is either field access or method call. All right, so there's some object or record, possibly an object. Yeah, it's an object called environment that has a field out to represent the std out. Interesting. So this is definitely an object that comes from a class. Cool. Cool. It is very different from the way you would define an actor in Erlang, right? That you have this primitive of a process, and a process is just a function being evaluated concurrently somewhere inside of the runtime. That, of course, can simulate state by recursion, but it can simulate long-lived, mutable state by recursion. But we'll see how the actors handle their life cycle. I guess. I don't know. All right, let's go into the types. The type system is what makes it special. There's plenty to love about it, but in the end, it's a type system that contains much of what makes Pony novel. In this chapter, we're going to explore the basics of the type system. If you worked with a statically typed language before, there shouldn't be anything surprising to you. By the time you finish this chapter, you should have a handle of basics of the Pony type system. Classes, primitive actors. Let's do the type system at a glance, and let's skim through classes, primitives. I want to spend some time in the actor section. All right. Am I live? Is this thing live? Yeah, it seems to be live. Okay. For some reason, I can't seem to open the chat on. Am I live? Is this thing live? Oh, there you go. Yeah, that works. Cool. There you are. This means the compiler knows the type of everything in your programs, statically typed. This is different from dynamically typed languages such as Python, Lua, JavaScript, and Ruby. Dynamically type language, a variable can point the object of different types at different times. This is not entirely true. Erlang is dynamically typed, right? But the variables are immutable, so you bind the name once and that's it. This is flexible because if you have variable x, you can assign an integer to it, then assign a string to it, and you compile and interpret. Or yeah, I'm not sure. This could be rephrased, I guess. But what if I try to do a string operation on x after assigning an integer to it? Generally speaking, your program will raise an error. You might be able to handle the error in some way, depending on the language, but if you don't, your program will crash. When you use a statically typed language, a variable has a type. That is, it can only point to objects of a certain type. Although pony, a type can actually be a collection of types, as we'll see later. If you have an X that expects to point to an integer, you can't assign a string to it. Your compiler complains, and it complains before you ever try to run the program. So types are guarantees. When the compiler knows what types things are, it can make sure some things in your program work without you having to run it or test it. What? Are you saying that with types I don't need tests? No. These things are the guarantees that a language type system provides. All message passing is causal. There will never be unhandled exceptions. There will never be a data race. Yeah, I'm not entirely sure what you mean by causal messaging. I understand the difference between casual and causal. But I want, one of this. What is the semantical implication of you using this word in terms of the evaluation of the message passing between actors? I'm not sure. Okay, so classes. You can create a class. So use let and var to specify different fields. So you have fields, constructors, and functions. I guess constructors are with new, fields we're going to be with var, and functions are with let. No, okay. So var can be reassigned, but let is immutable. You assign it in the constructor and never again. And embed. What's embed? Alright, so underscoring something means it's private. Okay, constructors. Pony constructors can have names. Alright, this is what we saw before. You have new, and then create, and hungry. And you sort of have to specify all the variables at some point, I guess. I don't know about var. Okay. We can type some of this in. Where is it? Yeah. Main. If you say wombat, and the wombat will have a name, which is a string, and we will have a hunger, which is an unsigned 64. I guess this would be string like that. So if we give it create, then we get a name in here. Then we can say name will be equals to name prime, and that should be all. Yeah. We also need to define the hunger level, but let's see what happens when we compile this. Field left undefined in constructor. Okay. Hunger 0. What's it saying? So I'm having some linking warnings. The runtime of Pony, so there is a runtime. I was mistaken. I said they didn't have one, but it does. Okay. Runtime Seems to have been built for newer OS X version than the one being linked. What the hell? But I already have the latest one, I believe. I don't know if I should do that. Okay. So Hungary. Rather, I don't know if this is an underscore language or. Okay. Cool. So I guess here we could just say let wombat will be a new wombat name Wato. How do we define methods? Functions. Fun. Okay. So fun. Yeah, okay, that's the one that we wanted. Hunger. U64. And we just return hunger. What? Why? Okay, so what I tried to do was having defined a wombat that looks a lot like this, right? I tried to get define a function that will essentially access the hunger level. Functions important like methods in Java, or pretty much any other object-oriented language. They are introduced with the keyword fun. They can have parameters like constructors do, and they also have a result type. I really want to know what none is. Oh, so curious about it. Please let it be. Let it not be like Python's none. The first function, hunger, is pretty straightforward. It has a result type, U64, and returns the hunger level, which is a U64. The only thing is a bit different here is that no return keyword is used. And you can return LA. So I'm starting to feel that the language tries to be a little hybrid between expression languages and statement languages. Okay, FP and OOP. And while I appreciate some of it, the other bits I feel might make in a way of writing cleaner code. But of course, that's highly subjective. I'm gonna also throw in another. Cool. We have music. And when you want to do a setting, you do a ref function. Okay, that's a reference capability. Okay. So there's syntax for some of these capabilities. A ref type is a reference type, meaning that the object is mutable. We need this because we are writing a new value to the hunger level field. Right. So the box capability. Okay. Capabilities then seem to be this layer or of orthogonal semantics that determine what you can and can't do with a particular object. I wonder if they are applicable to actors as well. Okay, so first things first, I want to know why I can't define hunger there. Oh, wait. I can't print this. I wonder if there's a print U64. Nope. Alright. Fair enough. You win. So this should build, and then I should be able to build it, and it runs. Okay. So we're using classes to essentially encapsulate data and methods and procedures, and we're using actor to orchestrate them. Is this what we're doing? One sec. And I am back. Okay, so we found out that we got a glance into capabilities, right? And we found that to be able to modify, to mutate a particular object of that's instance of a class, we need to specify that a particular method will require a capability. In this case, is ref. Now, I was expecting capabilities to be something a little bit more less baked into the syntax and more, I don't know how to say it, a little bit more like generics maybe syntactically, where you would say this method is constrained by these particular capabilities, rather than, hey, here's a keyword that is linked to a capability. But it might be that it's very useful to do it at the syntactic level because you end up using these things very often, right? So syntax just gets all of the ceremony out of the way, which is good. Okay, so we went through this. We found that there is a return, but you can also use the expressions, returning the last expression of the function. We found out that by default, the capability that we're using is box. So I would expect then this box to actually be, okay, is it a keyword? Right, I guess you can just drop in capabilities there. No, not all of them. Okay, so some of them are keywords. Okay. What would happen if we left the ref keyword off the setHunger method? The compiler will give you an error. It will see you're trying to modify a field and complain about it. You have defaults for the properties and defaults for the functions as well. Okay. This is a default argument. It means that if you don't include the argument at the call side, you will get the default. In this case, 2 will be 0 if you don't specify it. What does the function return? It returns the old value of hunger level. Yes, importing assignment is an expression rather than a statement. That means it has a result. This is true of a lot of languages, but they tend to return a new value. In other words, given A equals B in most languages, the value of that is the value of B. But in Pony, the value of that is the old value of A. Why? It's called a destructive read, and it lets you do awesome things with a capability secure system. We'll talk about that later. For now, we'll just mention that you can also use it to implement a swap operation. In most languages, right, yeah. You need to do something like this. In Pony, you can just do B equals A, right? Assigns A to B, but returns the old value of B. So you can assign that to A. And finalizers are special functions. They are named _final, take no parameters, and have a receiver reference capability of box. In other words, the definition of a finalizer must be final. I wonder if the syntax actually... Finalizers are usually used to clean up resources allocated in C code. Look like file handles or network sockets. Okay, so in some object-oriented languages, a type can inherit from another type, like how in Java something can extend something else. Pony doesn't do that. Instead, Pony prefers compositions to inheritance. In other words, instead of getting code reuse by saying something is something else, you get it by saying something has something else. On the other hand, Pony has a powerful trait system similar to Java 8 interfaces that can have default implementations, and a powerful interface system similar to Go interfaces, structurally typed. Naming rules. All names in Pony, such as type names, method names, environment names, may contain only ASCII characters. Okay. Right. So primitives. Primitives are similar to classes, but there are two critical differences. They have no fields, and there's only one instance of a user-defined primitive. Having no fields means primitives are never mutable. Having a single instance means that if your code calls a constructor in a primitive type, it always gets the same result back. What can you use a primitive for? The streaming uses, marker values, enumeration types, and collections of functions. So, like a module? Pony often uses the primitive none to indicate that something has no value. Okay. So it is like in Python. As an enumeration, I mean, not as in the language, but I can't quite recall. So let's just go into it and say what the hell is none. I want to say type of, but I don't get any completion. No. I'm embarrassing myself live. As far as I know, none in Python is actually a value on its own. It's sort of like the null of Python. I don't know. If you know better than I do, please let me know in the comments, and we can clear this question up. It'd be very nice to know what the relation between Pony's none and Python's none is. You can use primitives, right, as enumerations. By having a union of primitive types, you can have a type-safe enumeration. We'll cover union types later. Okay. And as collections of functions. Since primitives can have functions, you can group functions together in a primitive type. You can see this in the standard library, where path handling functions are grouped in the primitive path, for example. Alright, so now you seem to be able to put functions in groups, right? Group them in classes, primitives, and actors. I am confused. Is it that primitives have only static functions, but classes don't actually have static functions? As a collection of functions, okay. And then we have some code here where we have open and closed door. And we say the door state will be one of this. We can do primitive basic math, which has... And then on top of this, you have traits and interfaces. Unlike enumerations, in other languages, each value in the enumeration is a complete type, which makes attaching data and functionality to enumeration values easy. Built-in primitives. Okay. Right. So is there something like static? No. So I reckon that methods actually have to operate on the class, but if you wanted to add essentially fun salute, and this will take a wombat from the class, right, and will return a string, and they will say what did it say? Oh. Expected method body after, but I did give you a method body. Primitive wombat. All right, we need the method body here, and then we can say wombat.salute, and then we say, okay, so this can have the same name. Wombat utils. And then we say wombat create. We say tombat. Tombat the wombat. Aha. So perhaps we can say let this will be the wombat, right? And then this is the salute, right? And then we do amp out print s. Hello there. And I do not know if this is going to work out, but I'm going to give it a shot. All right, that seemed to work. Cool. Okay, so we can use this as collections of functions, static functions that have no context whatsoever. We can use classes essentially as functions over closure of all of these variables. And we can use actors to orchestrate how they behave together. Interesting. So it seems that we can do matching on types, and this should be exhaustive. Oh, okay. And of course, that's not how you do if analysis. I wonder if I can do matches here. True. False. And then end. Can I do this? Match. Okay. But I am returning anything. So let's say what the errors read like, right? Function body is in the result type. Match is not a string. Function body type string value on non-value. False, you seem satiated. And I don't understand. This should be a string. Why wouldn't this be a string? Okay, so that works. Cool. And now we can use it. We can say print out that thing, and then also the hunger will be wombat utils, and then is hungry, and then wombat, and then amp out. Oops. Env. Hungry. Compile. Run. You seem satiated. But if we create it with hunger, so we will give it a name. I reckon that are these name parameters or not? Let's go with no. 20. You seem hungry. Okay, cool. Son of man. Da-da-da. Alright, so there's some built-in primitives like boolean 1-bit value, integer, size, signed and unsigned integers, various sizes. All right. A little, how do you say? When you like something but you're not entirely sure yet. Let's move on. Actors. An actor is similar to a class, but with one critical difference. An actor can have behaviors. A behavior is like a function, except that functions are synchronous and behaviors are asynchronous. In other words, when you call a function, the body of the function is executed immediately, and the result of the call is the result of the body of the function. This is just like method invocation in any other object-oriented language. But when you call a behavior, the body is not executed immediately. Instead, the body of the behavior will be executed at some indeterminate time in the future. A behavior looks like a function, but instead of being introduced with the keyword fun, it is introduced with the keyword be. Like a function, a behavior can have parameters. Unlike a function, it doesn't have a receiver capability. Sorry, can have parameters. I don't remember if I said parameters or capabilities. A behavior can be called on a receiver of any capability. And you can't specify a return type. So what does a behavior return? Behaviors always return none. Like a function without explicit result type, because they can't return something they calculate, since they haven't run yet. Huh. Okay, so since behaviors are asynchronous, it's okay to run the body of a bunch of behaviors at the same time. This is exactly what Pony does. The Pony runtime has its own scheduler, which by default has a number of threads equal to the number of CPU cores in your machine. I'm starting to get interested in the runtime of this thing. Its scheduler thread can be executed an actor behavior at any given time. So Pony programs are naturally concurrent. Sequential. Actors themselves, however, are sequential. That is, each actor will only execute one behavior at a time. This means all the code in an actor can be written without caring about concurrency. No need for locks or semaphores or anything like that. When you're writing Pony code, it's nice to think of actors not as a unit of parallelism, but as a unit of sequentiality. That is, an actor should do only what has to be done sequentially. Anything else can be broken out into another actor, making it automatically parallel. Why is it safe? Because of Pony's capability secure type system. We've mentioned reference capabilities briefly before when talking about function receiver reference capabilities. The short version is that they are annotated on a type that makes all this parallelism safe without any runtime overhead. We will cover the references capabilities in depth later. And finally, they're cheap. If you've done concurrent programming before, context switches can cause problems. Each thread needs to stack. All right. The extra cost of an actor as opposed to one object is about 256 bytes of memory. Bytes, okay. So yeah, clearly I'm getting the feeling that when we do write some Pony code, we will try to write out data structures with classes, right? And write common algorithms or common functions in primitives, and orchestrate different classes that sequentially have to perform some work in different actors. There might be actors that do some orchestrating work so that they can, for example, start 1,000 other actors to be able to to parallelize some of the work that has to be done. But each one of those actors, the children actor, right, is going to be executed sequentially. Now, I didn't read anything about preemptive scheduling or cooperative. Yes. Interesting. Okay, so we have the three different ways of building things. Completely synchronous, completely stateless, and completely asynchronous. Traits and interfaces. Putting a subtyping, that is, some types serve as categories that other types can be members of. There are two kinds of subtyping in programming languages, nominal and structural. They're subtly different, and most programming languages only have one or the other. Pony has both. One second. Nominal subtyping. This kind of subtyping is called nominal because it's all about the names, right? Like in Java, for example. If you've done an object-oriented programming before, you may have seen a lot of discussion about single inheritance, multiple inheritance, mixing traits, and similar concepts. These are all examples of nominal subtyping. The core idea is that you have a type that declares it has a relationship to some category type. In Java, for example, a class, which is the concrete type, right, can implement an interface. Traits, nominal subtyping. Pony has nominal subtyping using traits. A trait looks a bit like a class, but it uses the keyword trait. We can actually extend this thing to be more representative. So trait named, and then it has a name, which is a string. And I expect this to work. Oops. How do we define it? Oh, okay. So traits are actually for functions. Then. That was a door that closed via the wind. So if we make this private, then we can say fun, name, and then nothing. By default, we can just say what. So if we build this, now the salutation will actually have to call name on this, I believe. And it seems to have worked. Right. But then that means we're using the default behavior rather than using the actual name that we wanted to use. Right? So I wonder if we need to override this name like that. Yeah, that works. So now we can just expect in utils, we can just say if you have something that's named, then that works. If you have something that's hungerable, that's a terrible name, but then you can call hunger on it. I guess starvable. How can we implement multiple traits? Name and, okay. It's named and starvable. And of course we don't have one but utils anymore, we just have utils. And this continues to work. Good. So we have used classes and traits here. So Okay, we can do multiple line comments. We are using an actor to initialize the program and orchestrate some classes and primitives in a sequential yeah. Oops. Something I'm missing here is a pretty printer. It would be very nice to have not to have to worry about what is, what are the conventions around this. Okay, so let's keep reading. Traits, nominal subtyping. Pony has nominal subtyping using traits. The trait looks a bit like a class, but it uses the keyword trait, and it can't have any fields. Here we have a trait named that has a single function named that returns a string. It also provides a default implementation of name that returns the string literal Bob. We also have a class Bob that says it is named. This means Bob is in the named category. In Pony we say Bob provides named, or sometimes simply Bob is named. I guess if your traits have names of adjectives, right? Then you can easily say class, and your class have names, have nouns. This is okay. Well, happens to be also a word, right? Noun. Then you can easily say noun is adjective, and it will work. Since Bob doesn't have its own name function, it uses the one from the trait, but then you can of course re-implement it. Cool. I guess that we probably don't want to have default implementations. We could just remove these things from here, and everything should compile just fine. It's also possible to combine categories together. In the example above, all bold class all bold. How do you pronounce things? Bold. Classes are automatically named. Consequently, the Bob class has access to both hair and name default implementation of the respective traits. So default implementations of both hair and name will be available to the Bob class. Or rather, yeah, it will be available. One can think of the Bob category to be more specified than the name one. Here we have a class Larry that has a name function, but Larry does not provide named. Why not? Because Larry doesn't say it is named. Remember, traits are nominal. A type that wants to provide a trait has to explicitly declare that it does, and Larry doesn't. Structural subtyping. There's another kind of subtyping where the name doesn't matter. It's called structural subtyping, right? It essentially checks the structure of something, and if it matches what you're looking for, then that's good. Which means that it's all about how a type is built and nothing to do with names. Right. A concrete type is a member of a structural category if it happens to have all the name needed elements, no matter what it happens to be called. If you use Go, you'll recognize that Go interfaces are structural types. Interfaces, structural subtyping. Pony has structural subtyping too, using interfaces. Interfaces look like traits, but they use the keyword interface. Okay. Yeah. Interesting. So, off the bat, this thing is interesting as well. The fact that traits stop accidental subtyping, right, means that they are safer to work with. But also, if you have a class somewhere, and I'm seeing all of this applied only to classes, so I don't know if they apply to actors at all. But essentially, interfaces work in a way that if you already have a class defined somewhere, right, you can create a new interface and it will automatically implement that interface if it complies with the structure that the interface is expecting, right? So has name as an interface is essentially declaring a contract. So if any class you have has the name interface, right? Sorry, it has a name function that returns a string, then it will be of the has name type, which is to say that Larry here has this type, but also that Bob has that type as well. So Bob both is named and also has name. And I get why they're using this language, right? Bob is bald is to say that you know that Bob is bald and Larry happens to have a name. That's why it has name, I guess. That's my guess. But all right, this seems to be a fairly large language. You have 3 different ways of structuring your application, and furthermore, you have 2 types of subtyping that you can use, both nominal and structural. I'm not saying that's a bad thing, not at all. It's definitely, it's good to have more tools in your toolbox to work with. I just didn't know it was going to be this big. That's all. Let's go into type aliases, and then we can take a small break. A type alias is just a way to give a different name to a type. This may sound a bit silly, after all, types already have names. However, Pony can express some complicated types, and it can be convenient to have a short way to talk about them, right? We'll give a couple examples of using type aliases just to get the feel of them. Enumerations. Okay. So this is how you do more complex sort of records, or compound sets of data. All right, let's go through this. But before we do, I wanna try something. We can do trait has name. Sorry, interface has name, right? And then fun name string. So now Wombat actually is named, but also has name. And I would like to see if I can make a new actor, right? Saluter. I don't really know how to create actors though. I guess I could say saluter.create, and I give it the environment. So I will say actor saluter. Right? And the last thing I'd like to have a look at is whether traits can be used for actors. So trait salutes. And then B okay, it seems that we can use traits for actors as well. So if I say actor saluter is salutes, then I expect an error. And I guess that we want to call salute with the environment like that. Okay. I need the environment here. Compiles, nice. So if I do this, then we get the same thing out. Cool. All right. So we can use traits as well to define how actors are going to behave. And I reckon that if we can use traits, we can also use interfaces to say, hey, this actor actually has the name, or will salute, or whatever the interface is like, which is interesting. After we get familiar with the type system, we'll try to build a small program. Hopefully the tutorial will guide us through building a small program with this. Okay. So a type alias is just a way to give a different name to a type. This may sound a bit silly, after all, types already have names. However, Pony can express some complicated types, and it can be convenient to have a short way to talk about them. We'll give a couple examples of using type aliases just to get the feel of them. Enumerations. One way to use type aliases is to express an enumeration. We saw that before. You have three primitives, you put them together with ORs, and then bam, you have your enumeration. Which I reckon that if each one of these actually is a trait, right, then you, or an interface, you sort of have a way of having a variant type, right, that for each one of its constructors, it will let you have some data inside of it. But it's a tad more flexible. The first is the type alias, introduced with the keyword type. It just means that the name that comes after type will be translated by the compiler to the type that comes after is. So this is just a macro. The second new concept is the type that comes after is. It's not a single type, instead it's a union type. You can read the pipe as or in this context, so the type is red or blue or green. A union type is a form of closed world type. That is, it says every type that can possibly be a member of it. In contrast, object-oriented subtyping is usually open world, unless you do final in your classes or interfaces. In Java, an interface can be implemented by any number of classes. Okay, no, that's absolutely right. But I'm not entirely sure what the relation between these two things is. So I guess this is really just trying to... These are not values that belong to the same type. These are actually different types. You can also declare constants like in string or go like this. So you apply them, and that's the value. Or namespace them. Tag. If a type is complicated, it can be nice to give it a mnemonic name. For example, if you want to say that type must implement more than one interface, we could say this and this and this. So has name and has age and has address. And you can also do this with traits. So when you say that something is a person, then you're expecting it to have all of these traits implemented. So instead of saying that wombat is named and starvable, well, I guess these two are orthogonal in the sense that what is something that is both named and starvable? A pet, for example, right? Cool. So we define the pet alias to mean both named and starvable, which really is just a guarantee on some of the things that we will find in our class. We may find many, many more, but no less than these two. Okay. There's another new concept here. The type has ampersand in it. This is similar to the pipe of a union type. It means it's an intersection type. That is, it's something that must be all of has name, has age, and has address. But the use of type here is exactly the same as the enumeration example above. So we probably want to do, we have primitives, but we can do primitive, primitive starve, primitive satiated, and then we can do type hunger is starved or satiated, right? So now we can say starvable has a hunger that returns hunger, so we get rid of that that integer essentially. And now we can just change our hunger. I guess the compiler is gonna scream at us, hey, what is all the stuff? Hunger, and then if you give it a hunger, then it will work, and then hunger returns a hunger level as well. Cool, so now we essentially need to match differently. We no longer have a 0 there. It's either, starved or satiated. And if we do that, then I expect less errors to appear. Okay, so we don't have a string type in here, but I'm pretty sure we saw this at the beginning. Maybe in primitives, right? Closed door, built-in primitives. What do we see a way of turning a primitive into a string? Okay, so I guess we now don't really have any more information than starved. You seem hungry, so we could just do that. So when we say with hunger, we will say starved. And where is there? Okay. Then the default value will be satiated. Cool. So we just refactor the program to actually use a union. We use primitives values without any functions to signify singleton values, I guess markers. We can put them together in a type alias with a pipe to turn them into enumerations. Cool. I am starting to see the power of this thing. I'm gonna crunch them together. And we use traits as a way of saying this should have certain attributes, and interfaces as a way of saying, actually, They should have. So I guess we use both mechanisms to ensure that something has certain attributes of saying and they're both using for enforcing these things. So we use traits. To enforce attributes in a class or actor by specifying what traits it should implement. No, okay, I'll just write it down and then we'll see why it's wrong. What traits it should, what traits it implements. So this could also be at the definition site. Okay, so we can use traits to say what attributes are available in our class or actor, and we can use interfaces to inspect. Now that's not exactly true either. So the true difference seems to be very subtle. I'm making a fool of myself trying to write down why. So yeah, I don't, and that's exactly what I don't want to just throw. You know, I don't want to just say, yeah, we use traits for nominal type subtyping and we do interfaces for structural subtyping. I want to. Maybe there's no better way of doing that. We can use traits for nominal subtyping and interfaces for structural subtyping. We can define aliases, which is bet, to mean this will be products. Okay. Where's the 80th line? There you go. Okay. Cool. Yeah. We use primitives with only functions as a way of grouping together can use primitives to group functions too. All right, whatever. That should be okay. That should be enough for now. Let's move on. We said enumerations, we had complex types, and then we were reading somewhere on here. But the use of type here is exactly the same as the enumeration example above. It's just providing a name for a type that's otherwise a bit tedious to type out over and over. Another example, this time from the standard library, is set is. Here's the actual definition. Set is, for some type A, right, is a hash set that has the first type of A and has a second type parameter that's hash is of whatever A is with a bang. I don't know what the bang is for. There's something in here. After the name set is comes the name A in the square brackets, a type variable. That is, you can give a set is another type of parameter to make specific kinds of sets. If you use Java or C, this will be pretty familiar. If you use C++, the equivalent concept is templates, but they work quite differently. And again, the use of type just provides a more convenient way to refer to the type we're aliasing. That's another generic type. It means a set is really a kind of hash set. Another concept has snuck in, which is bang types or exclamation mark types. This is a type that is the alias of another type. That is tricky stuff that you only need when writing complex generic types, so we'll leave it for later. One more example, again from the standard library, is the map type that gets used a lot. It's actually a type alias. Here's the real definition. Map takes a k, right, which has to comply with this constraint, which is both hashable, a box, right, that is hashable, so you can only read from it, right, and a box that's a comparable of k, and some type v. And this is just a hash map, which is a key v and has a hash equality, I guess, parameterized by k. Unlike our previous examples, the first type parameter k has a type associated with it. This is a constraint, which means when you parameterize a map, the type you pass for k must be a subtype for the constraint. Also note that the box appears in the type. This is a reference capability. It means that there is a certain class of operations we need to be able to do with a k. We'll cover this in more detail later. Just like our examples, all this really means is that map is really a kind of hash map. Okay, other stuff. Type aliases get used for a lot of things, but this gives you the general idea. Just remember that a type alias is always a convenience. You could replace every use of the type alias with the full type after the is. Interesting. So I wonder what a hash map ends up as, right? Unless this is an interface or a trait. Maybe it is. Maybe it is. Or primitive. Let's go to type expressions. Cool. So we have tuples, unions, and intersections. We talked about so far, the types we talked about so far can also be combined in type expressions. If you're used to object-oriented programming, you may not have seen this before, but they are common in functional programming. A type expression is also called an algebraic data type. There are three kinds of type expressions: tuples, unions, and intersections. Tuples. Tuple is a sequence of types. For example, if you wanted something that was a string followed by a U64, we would write this. So we have the tuple there, right? All type expressions are written in parentheses, and thus the elements of a tuple are separated by a comma. We can also structure. Okay, I guess there's a subset of this language that I'm already liking, but or we can access the elements of a tuple directly, first and second. Unions type are written like a tuple, but it uses the or instead of a comma between its elements, where a tuple represents a collection of values. A union represents a single value that can be any of the specified types. Unions can be used for tons of stuff, right? So string or none. So I guess this is how you do nullability, right? This is how you take a look and say, hey, I don't know if I'm going to have an answer, so I'll give you the string or none. I wonder if they have a result type. I might also be very biased by the type systems and the conventions of other functional programming languages when it comes to languages like Pony, where you have this. And this might be perfectly acceptable for many people. I just grew used to having a result, for example, where it's either a value or there's an error of some sort. Or in this particular case, what would be more suitable would be an option, right? Either you have some string or you have none. So I would have expected a type, right? I don't know if you can have right? So then you can say trait none like that. I don't know if that would actually compile. And it does. Okay. So I wonder if we can say class option is option of A. I wonder if I actually want to have a primitive instead of this. Anyways, this is probably wrong. Okay. And then intersections between its elements either represents the exact opposite of a union. It's a single value that is all of the specified types at the same time. You can combine type expressions. All right. So what are expressions in Pony? We've looked at the types, and the type system sort of makes sense. We found all of these things over here. I'm just actually gonna open a README. Horsing around. With PonyLang. Check out PonyLang. Oops. Is that the URL? No. Oh, ponylang.io. Okay. And I always forget how to do this. Language, okay. Cool. So I just need to create the repo. Yeah, by the way, the code I'm writing, I'm gonna make available in the horsing around repository. So I can just say, exploring the Pony language. Public. Git, what is it? Remote. Cool. So I'm gonna be putting all the code here, possibly in more than one file, but right now it's just here. Oh, you have a syntax in GitHub. This is amazing. Awesome. Really, really cool. Okay, okay. So you can follow it later on if you're interested in it. Yeah, I don't think we're gonna use the playground, but okay. Literal variables, arithmetic, control structures, methods, errors. Okay. So I guess we can skim through this very quickly. I'm gonna take 5 minutes now, possibly less. I'm gonna get some water and stretch my legs. Okay, I'll be right back. And I'm back. All right. So where were we? Expressions. Literals. What do we want the values? Where do we want them in our programs and more? Every programming language has literals to encode values of certain types, and so does Pony, bools, numeric literals, characters, strings are double quoted or triple quoted. All string literals are multi-line. Okay, cool. Array literals have type inference. So if you try to put things, okay, you can do heterogeneous arrays because you can do essentially ORs at a type level. And the type has a ref at the end. Okay. If the variable or call argument to the array literal assigned to as a type, the literal is coerced to that type. It's stringable. And we have an expression to actually cast things. It's also possible to give the literal a hint on what kind of type it should coerce the array elements to using an as expression. The expression with the desired array element type needs to be added right after the opening square bracket delimited by a colon. Right. So there is type coercion, but there isn't type coercion that goes beyond the traits and interfaces that the classes and primitives are implementing, which is interesting. Constructing an array with literal creates new references to its elements. Thus, to be 100% technically correct, array literal elements are inferred to be the alias of the actual element type. If all elements are of type T, the array literal will be inferred as T-bang array ref. This is an array of aliases of the type T. It is thus necessary to use elements that can have more than one reference of the same type. Types with val or ref capability. Oh, I can't wait to get into capabilities. Or use ephemeral types for all the capabilities, as returned from constructors or the consume expression. So there's something to be read of literals for arrays. All the other literals seem pretty straightforward. Let's go into variables. You have local variables, and I'm just skimming through this because I expect most of us to be familiar with it. But if you're not, take your time and read through it. I'm pretty sure that the documentations are good. So far, the prose, the style, the tone, all of them have been very welcoming, very understanding. They've helped me understand what was unclear. There's been examples of it, so I think this shouldn't be an exception. Okay. So we can define a var with a type and then initialize it. Right, okay. So either you initialize with a type or with a value, so you can infer the type, but you can't really say, hey, var z, and that's it. There's block scoping. Huh, look at that. Var versus let. Local variables are declared with the var let. Using var means the variable can be assigned or reassigned as many times as you like. Using let means the variable can only be assigned once. Okay, so using let also means that you need to assign immediately. Fields. Fields are the things that live within objects. They also work like fields in other languages, object-oriented languages. Underscore is a private, which I reckon they took from Python conventions. Otherwise, it can be public, can be read or written from anywhere. So if you say var name, then you'll be able to modify this. And if you say let underscore hunger level, then you won't be able to modify it from anywhere. And it will also be private. Please note that the assignment of value to a field has to be explicit. The below example raises an error when compiled, even when the field is a var type. Right. Field declarations cannot come after constructors. Or it looks like we could read this. Just like local variables, fields can be var or let. Nevertheless, rules for field assignments differ a bit from variable assignment, right? No matter what the type of the field, in the var or let, either 1, an initial value has to be assigned in their definition, or 2, an initial value has to be assigned in the constructor method. In the example below, the initial value of the two fields of the class Wombat is assigned at the definition level, right? They have defaults. And then in the second example, we see that we are assigning them in the constructor. If the assignment is not done at the definition level or the constructor level, an error is raised by the compiler. Cool. All right, so all fields will be defined if you get an object of a particular class, which I think is a good idea. And also, I like this, but I understand why it would be convenient to be able to use your setters, right? So essentially, if you had complex logic for setting the hunger level, you would have to replicate it here. Or I guess that if the logic was, you could extract it into a different method that just computes the logic and then computes the value, and then you would assign the hunger level in here by calling get hunger level, right? And then it would do it there. So that shouldn't be a problem. We will see later in the method section that a class can have several constructors. We saw that already. Just remember that if the assignment of a field is not done at the definition level, it has to be done in each constructor of the class the field belongs to. Right. As for variables, using var means a field can be assigned and reassigned as many times as you like in the class. We've seen this already. Using let means the field can only be assigned once. Again, if you use lets, then you just set it in the constructor and you're done with it. Can field declaration come after the constructor? No. To keep Pony's grammar unambiguous, only type aliases are allowed between actor name and object is straight, etc., which is the first line that we see here, right? And a field definition, in any case, in any case, it's good style to make such variables easily visible to the programmer because fields are accessible from any method of the type they're in. Can actors have fields? Let's. Expected. Oh, right. Maybe repeat is a reserved word. I wonder if this works too. No, you need to give it a type. I would have liked the inference to kick in, but I guess it's clearer to see in the definition of the actor, hey, this field is of this type, rather than have to make human inference on it. One second. Right. So going back to Brave. Unlike local variables, some types of fields can be declared using embed. Only classes or structs. There's also structs. I'm confused. No. Okay. Can be embedded, interface, traits, primitives, and numeric types cannot. A field declared using embed is similar to one declared using let. But at the implementation level, the memory for the embedded class is laid out directly within the outer class. Okay. Contrast this with let or var, where the implementation uses pointers to reference the field class. Embedded fields can be passed to other functions in exactly the same way as let or var fields. Embedded fields must be initialized from a constructor expression. So, right, okay, so you avoid a pointer indirection, which is good for performance purposes. Separate memory location when creating the field. By default, it is avoid to use embed if possible. Right, exactly, yeah. However, since an embed field is allocated alongside its parent object, exterior references to the field forbids garbage collection of the parent, which can result in higher memory usages if field outlives its parent. Good to know that we can't do this, right? we have a way around it. Globals, some programming languages have globals. What a bad idea, Pony doesn't have global variables at all. I guess you can define a primitive, and I wonder if primitives can have values inside, like let mark string. And this will be like a constant. Can have fields, all right. I guess traits also can have fields. Yeah, you will have to have some sort of class and singleton actor somewhere then, or singleton object. But then how will you carry that around? I don't know. I guess you just can't. We'll see. We'll see. Shadowing. Some programming languages let you declare a variable with the same name as an existing variable, and then there are rules about which one you get. This is called shadowing, and it's a source of bugs. If you accidentally shadow a variable in Pony, the compiler will complain. If you need a variable with nearly the same name, you can use prime. Thank you for this. Thanks a lot, really. I like using prime in my variable names. Infix operators, operator aliasing. Can you define operators? This is what I'm looking for right now. We have a table for a bunch of them. And I don't see anything about defining operators, which might be a good thing. Okay. Arithmetic. Pony's default arithmetic. Interesting. Okay, so you have safe and unsafe arithmetic that does no checks. Okay, so you can use this consciously. I'm sort of glossing over this because I really want to get into the capabilities. I haven't seen any message passing yet either. So I'm curious if we're going to get to that. But I want to check control structures and errors and partial applications. So we'll just race through the others to see what's happening. We have conditionals, like we saw before. You can nest them. You have else if for collapsing the nesting. Everything is an expression. Thank you so much for this. You have matches where you have none. While, some breaks. Right. This is more or less familiar. Functions or methods. Constructor functions and the calling. You pass in parameters. Just glossing over again. Default arguments we saw already. Named okay, this is new. Named arguments. Or this is known as positional arguments. Okay. Show me the syntax. So essentially, if I wanted to use named arguments, let's say here, right? When I say with hunger, I would say this is the name, and then with hunger, and then like that. Now where? Or equals. I forget. Okay, it's an equals. Okay, so there's no comma between the last argument and the... There you go. That should compile, except that it didn't. And it doesn't because for some reason we have a prime here, which we can't get rid of because the function is also called hunger. That's annoying. But I guess it's just how we wrote down things in this example. Okay, so that works. Cool. Chaining. Method chaining allows you to chain calls on an object without requiring the method to return its receiver. Right, so this is just, again, syntax around it. I think that's encouraging a lot of OOP patterns that I'm not very fond of. We do have lambdas though, so you just put them in braces. They have parameters in parentheses. This is nice. Good to know that we can use lambdas as first class values. Oh, you can't name things with more than 2 underscores. More than 1 underscore. Very restrictive syntax. Okay. Errors. Pony doesn't feature exceptions, as you might be familiar with them from languages like Python, Java, C++, and so on. It does, however, provide a simple partial function mechanism to aid in error handling. Partial functions and the error keyword used to raise them look similar to exceptions in other languages but have some important semantic differences. Let's have a look at how you work with Pony's errors and then how it differs from the exceptions you might be used to. Oh, so that's what it means by okay. Partial functions are functions that are not total, that may not always return a value. An error is raised with the command error. At any point, the code may decide to declare an error has occurred. Code execution halts at that point, and the call chain is unwound until the nearest and closing error handler is found. This is all checked the compile time, so errors cannot cause the whole program to crash. Error handlers are declared using the try-else syntax. Could have been try-catch. Then can the error actually have any information? In the above code call A, it will always be executed, and so will call B. If the result of call B is true, then we will proceed with call C in normal fashion, and call D will not then be executed. But if call B fails, or rather returns false, then an error will be raised. Do I have to provide an error handler? No, the try block will handle any error regardless. If you don't provide an error handler, then no error handling action will be taken. Execution will simply continue after the try expression. Okay. Is there anything my error handler has to do? No. If you provide our handler, then it must contain some code, but it's entirely up to you what it does. Okay, so whatever the last expression of the try block was, that's a return value. I don't get it. Why would you do this? Why would you introduce this when it's perfectly achievable through the constructs you already have in the language? Either by pattern matching on call B to make sure that what you get back is the right value and continuing and branching off. I don't think this makes it any clearer to see what's going to happen, right? Because you may have multiple errors being thrown from different parts of the expression inside of the try, and then they all are caught by the same else, which means either the same else works for everything, or it will essentially force you to have some mutable state outside of the try to be able to decide what error was and how to handle it. Okay. I think this is a bad idea. So far, I'm really liking the things I'm looking at. It's a very broad and complex language that lets you specify many things in different ways. This one is something I don't like. Again, highly subjective. Partial functions. Pony does not require that all errors are handled immediately, as in our previous example. Instead, functions can raise errors that are handled by whatever code calls them. These are called partial functions. This is a mathematical term meaning a function that does not have a defined result for all possible inputs. And by inputs, it means arguments. Partial functions must be marked as such in Pony with a question mark, both in the function signature after the return type and the call site after the closing parentheses. Like this. So essentially, this may error. I wonder if I don't include that. Oops. If this will fail. Pony C. Okay. Cool. So I have to mark it as question mark. Interesting choice, question mark instead of like a bank. This to me looks like an optional value from other languages. Everywhere that an error can be generated in Pony, it must appear within a try block or a function that is marked as partial. This is checked at compile time, ensure that an error cannot escape handling and crash the program. Good. Right. Okay. Having every partial function call site clearly marked makes it very easy for the reader to immediately understand everywhere that a block of code may jump away to the nearest error handler, making the possible control flow paths more obvious and explicit. Still disagree with the decision, but I understand that this is better than not knowing when something is going to blow up and go to the first catch. Partial constructors and behaviors. If an actor constructor were to raise an error, it will already be too late to report this to the caller. So constructors can be partial. All right. And then you have with resources, I guess. Okay, so I guess there's an interface for this. So if you have a dispose function, then it will help you release resources. Pony errors behave very much the same as those in C++, Java, C#, Python, and Ruby. The key difference is that Pony errors do not have a type or instance associated with them. This makes them the same as C++ exceptions, would be if a fixed literal was always thrown, like throw 3. This difference simplifies error handling for programmer and allows for much better runtime error handling performance. The else handler in try expression is just like a catch in C++, catch exception in Java or C#, except in Python or rescue in Ruby. Since exceptions do not have the types, there is no need for handlers to specify types. Yeah, I'm torn by this. I really am. Equality, we have identity and structural equality. And I guess we have different operators for it. We have is and double equals. Yes. Okay. Sugar. Apply. Okay, if you define apply, then you can just call something. Create is the same thing. Not interested in this right now. Though the last one looked pretty interesting. Okay. So this will be update. Okay. Sorry. Object literals. Lambdas. Sometimes it's really convenient to be able to write a whole object in line. You can do object literals, and it does pretty much exactly what an object literal in JavaScript does. It creates an object that you can use immediately, but Pwn is statically typed, so an object literal also creates an anonymous type that the object literal fulfills. Anonymous classes in Java and C# are similar to this. Okay. So this is pretty much the same thing then. Except that you're defining this object. Or do you define a class? Alright, so this one is returning a hashable, right? So this is returning some value that is of type hashable. And the string comes from there. Okay, so you return values. Lambdas work in the same way. You can use the lambdas for that. A lambda is written as a function, implicitly named apply, enclosed in curly brackets. Right, just the same thing as doing this. They also can capture the lexical scope in the same way as the object literals can assign from the lexical scope to a field. Right. This looks like PHP, where you say with this thing. It's also possible to use a capture list to create new names for things. Right, so you can capture things here and separate them in comma. And you have actor literals. Okay. Partial application, last one, a simple case, add mul, and then you can write. Okay, so instead of using dot, you would use tilde. So I reckon that partial application is slow, since you have to create anonymous classes and return refs for each one of them. Okay, so far so good. Let's review capabilities. But where the hell is the message passing? Testing. Like, how do I get access to the name, the identifier, the mailbox of a particular actor to be able to send messages to them? I would expect that to be obvious by now, but maybe I'm reading the language very, very poorly. Okay. Pony patterns. Sorry, I'm just quickly going around trying to get an idea of whether there is such a thing as message passing in this language, or if I am just, completely mistaken. Examples. Yeah. Actor. All right. Capabilities. We've covered the basics of Pony's type system and then expression. These chapters about capabilities will cover other features of Pony's type system. There aren't currently any mainstream programming languages that feature capabilities. But what is a capability? It's the ability to do something. Usually that something involves an external resource that you may want to access, like the file system or the network. This is called an object capability. Object capabilities have appeared in a number of programming languages, including E. Interesting. What is E? Object-oriented programming language for secure distributed computing, created by Miller and Bornstein and others at Electronic Communities in '97. They have message passing, message-based computation with a syntax similar to Java. Let's see. There's a reference here. What seems to be a capability operating systems. The capability was first invented by secure operating system designers. It started as a way to protect primitive resources such as memory argument. Oh, this is from '66. This is fairly going back. It was generalized into a protected ability to invoke arbitrary services provided by other processes. For each process, there is a table associating small numbers, similar in spirit to Unix file descriptors, with the capabilities held by that process. The small numbers serve the same function as variable names do in the lambda calculus. In a pure capability operating system, such as KOS or EROS or EROS, a process's only source of authority is the capabilities that it holds. And this is interesting. Let's see. References, there we have one, and then we have Wolf 74. This one. Hydra, the kernel of a multiprocessor operating system. It's part of a book. A book on capabilities. A security kernel based on the lambda calculus. Interesting. This link is down. All right. In addition to object capabilities, Pony also features another kind of capability, also called a reference capability. Where object capabilities are about being granted the ability to do things with objects, reference capabilities are about denying you the ability to do things with memory references. For example, you can have access to this memory, but only for reading it. You cannot write to it. That's a reference capability, and it's denying you access to do things. Capabilities are core to what makes Pony special. You might remember in the introduction to this tutorial, we said that Pony is type safe, memory safe, exception safe, data erase free, and deadlock free. Object and reference capabilities are what make all that awesome possible. By the time you finish this chapter, you should start to have a handle on what capabilities are and how you can use them. Don't worry if you struggle with them at first. For most people, it's a new way of thinking about your code and takes a while to grasp. If you get stuck trying to get your capabilities right, definitely reach out for help. Once you've used them for a couple weeks, problems with capabilities are a mile away, but before that can be a real struggle. Alright, okay, scared, don't be ready, good, let's get started with object capabilities. Let's see what these are. Pony's capability secure type system is based on the object capability model. That sounds complicated, but it's really elegant and simple. The core idea is a capability is an unforgeable token that A, designates an object, and B, gives the program the authority to perform a specific set of actions on that object. So what's a token? It's an address, a pointer, a reference. It's an object. How is that unforgeable? Since Pony has no pointer arithmetic and is both type safe and memory safe, object references can't be invented, forged by the program. You can only get one by constructing an object or being passed an object. So you can break this from the CFFI. So I guess that potentially you could have a very tiny CFFI that forges references and then you get them back into the language. Interesting. So this seems to be similar to referential transparency as long as you think of the receiver as being passed to a method as well. Okay. So if the object is the capability, what controls what we can do with the object? How do we express our access rights on that object? In Pony, we do it with reference capabilities. Rights are part of a capability. If you open a file in Unix, you get a descriptor back. That file descriptor is a token that designates an object, but it isn't a capability. To be a capability, we need to open that file with some permission, right? Some access right. For example, file descriptor, it's an integer, open this location with read and write. Now we have a token and a set of rights. In Pony, every reference has both the type and reference capability. In fact, the reference capability is part of the type. This allows you to specify which of your objects can be shared with the other actors, and allow the compiler to check that what you're doing is concurrency safe. So it seems like the reference capabilities are similar to the borrow checker from Rust. Or I might have misunderstood both. In that it's a specific annotation that's part of the type system that helps the compiler force upon you, right, or help you live up to the promise that data that is mutable will not be shared across essentially isolation boundaries. Right, so like const, there seems to be some type qualifiers. Refs, which are mutables, or val, which are immutables. And I reckon by default, everything is... Alright, here's all the ones that we have, right? Reference capabilities can be isolated. For references to isolated data structures, if you have an ISO variable, then you know that there are no other variables that can access the data. So you can change it however you like and give it to another actor. Interesting. So val is the value is the default one for reference to immutable data structures. If you have a val variable, then you know that no one can change the data. So you can read it and share it with other actors. You have a ref. This is for references to mutable data structures that are not isolated, in other words, normal data. If you have a ref variable that you can read and write data however you like, and you can have multiple variables that can access the same data, but you can't share it with other actors. That makes sense. Otherwise, you need to do some locking and stuff, and it becomes messy. Box. This is for references to data that is read-only to you. The data might be mutable and shared with other actors, or there may be other variables using it in your actor that can change the data. Either way, the box variable can be used to safely read the data. This may sound a little pointless, but it allows you to write code that can work for both val and ref variables as long as it doesn't write to the object, right? So you can take a box out of the reference, right? So, perhaps a snapshot, or get exactly the value that the ref has right now, but without you being able to modify it. A transition. This is used for data structures that you want to write to and give out read-only variables to. Right, so you want to write to it, but you want other people to be able to read from them. You can also convert a transition variable to val variable later if you wish, which stops anyone from changing the data and allows it to be shared with other actors. Alright. So I guess you can't really write your own capabilities that are part of the compiler, which explains why they're keywords, which explains why we haven't specified them differently before. And lastly, we have a tag. This is for references used only for identification. You cannot read or write data using a tag variable, but you can store and compare tags to check objects' identity and share tag variables with other actors. Right, so there isn't such a thing as a mailbox, right? There is only tag actors. So when I create a new actor like I did here, saluter create, if this was saluter or A for actor, right? This will be a tag, essentially. I probably want to do let env will be a variable that I can't read or write from, but I can use to compare with other actors to see, are these two the same one? Do they have the same identity? But I would like to see if that prevents me from actually executing behaviors on the actors. that compile the length, and if I run it, it does run. Okay, so I can do that still. Good. Interesting. Reference capability guarantees, and this will describe opaque, immutable, mutable, and those are the three ones. So this describes a little bit deeper, in a more deeper fashion, what is it that the reference capabilities that we saw actually guarantee us. So they're going to talk about what's denied on each one of the capabilities that you grant to a particular variable. Okay, so the mutable references capabilities are ISO, transition, isolated, transition, and reference. These reference capabilities are mutable because they can be used to both read from and write to an object. If an actor has an ISO variable, no other variable can be used by any actor to read or write from that object. This means an ISO variable is the only variable anywhere in the program that can read from or write to that object. It is read and write unique. Interesting. If an actor has a transition variable, no other variable can be used by any actor to write to that object. And no other variable can be used by other actors to read from or write to that object. This means that a transition variable is the only variable anywhere in the program that can write to that object. Right. But other variables held by the same actor may be able to read from it. It is write unique. And I guess ref is the read unique. If an actor has a ref variable, no other variable can be used by other actors to read from or write to that object. This means that other variables can be used to read from and write to the object, but only from within the same actor. Why can they be used to write? Because they all stop others from reading from and writing to the objects. Since we know no other actor will be reading, it's safe for us to write to the object. Okay. And immutable reference capabilities prevent you from actually writing to things. We have val and box. Val variables, no other variable can be used by any actor to write to the object. I gotta say the wording of this is very confusing. It might be that I'm a little tired after 3 hours of horsing around with pwning. Yeah, I know, it's funny, right? This means that the object can ever change. It's globally immutable. If an actor has a box variable, no other variable can be used by other actors to write to that object. This means that other actors may be able to read the object and other variables in the same actor may be able to write to it. In either case, it is safe for us to read. The object is locally immutable. Why can they be used to read but not write? Because this references capabilities only stop other actors from writing to the object. That means there is no guarantee that other actors aren't reading from the object, which means it's not safe for us to write it. It's safe for more than one actor to read from an object at the same time though, so we're allowed to do that. Okay, so essentially when we say this is mutable, then other people can't read or write from it, right? It's internal to us. When we say it's immutable, with val or box, we're saying this is globally or locally immutable. Val essentially says this is the value, so this is just a binding a name to the value all across the program. And box says, in this context, this name means this thing, but this can change over time. Context including the time, right? And this is stopping other actors from writing to the object. Which means other actors can read from it, but can write to it. And lastly, the opaque references have tag. Why can't tag be used to read or write? Because tag doesn't stop other actors from writing to the object. That means if we tried to read, we would have no guarantee that there wasn't some other actor writing the object. So we might get a race condition. Interesting. Okay. So once again, the mutable reference capabilities are ISO, isolated, transition, and reference, right? And these capabilities are mutable because they can be used to both read from and write to an object. So essentially, isolated variables are read and write unique, meaning only one actor, right, can read and write to them. Transition variables are only write unique, meaning only one actor can write to them. That is, any other part of the program will be able to read from them and not write to them. Oh wait, no, this goes even deeper. I am confused. Okay, so essentially what I am understanding here is that when you declare a variable isolated, it means that only that variable can write itself. I think this section could use some code examples to make it a little more tangible. I'm not familiar with capabilities, so I'm trying to grasp them as I read them out loud, right? So what I think is that we could maybe try to get some small code examples for each one of this. So let's, I'm gonna just throw that in there, and oops, wrong window. Fine. Make that full there and throw that into the right. Cool. We'll make this a little smaller. Let's do a different split. Okay. And let's do a different file. So let's do capabilities.pony. Right. And what we want to try here is first making an isolated variable and understanding how that works. So far I think we have pony C works. It compiles. Great. So any error that we have should be from this new file, right? So if we do actor main or actor stuff test or whatever, create, and we get an environment of type env, right? In here, what I'm expecting is that if we have a class, I wonder how we can tuple or pair, right? Which has, I'm just gonna go with U64s. I'm not testing out this thing, right? Then I should be able to make this two. No, let's do a different example. Let's do a ref count or a counter. What's the biggest counter we can make? From 0 up to 128 bits. So when we do a new create, we have to pass it a begin or start value, right? And then it just says I will be start value. And I guess we can make this private. Or it should be fine to make it, keep it public. Okay, so if we say let C be a counter, right, with the start value of 0, then this should compile fine. Oh, okay. Why didn't you fail before? Cool. That works all right. Now, here we could just say counter and say ISO. That right side must be a subtype of left side. Huh. Right, and by default this is a ref. So do I do counter ISO? Do I do ISO counter? So that compiles. That doesn't work. Invalid syntax. So I am confused. How do I actually write this down? Right, so I can say the counter, so the class counter by default will be ISO, which is isolated, right? So this means that does this mean that I can't call c.I? No, I can't do that. But why? Wait, shouldn't that be an error? This is ISO. Oh. New ISO create. This is confusing to read. If an actor has an isolated variable, no other variable can be used by any actor to read from or write to that object. The fuck does this mean? I don't get it. This means an ISO variable is the only variable anywhere in the program that can read from or write to that object. Does this mean that, let's say if I had a counter printer, right? Does this mean that I can do this? Or does this mean that C, which is our ISO counter, right, is the only one that can actually access anything else in this actor? If you're there listening and watching the stream and have a better idea of what the hell does isolated mean in this context, please let me know. Nobody? Anybody? All right, so maybe if we do a function that expects it to be ISO and we say inc, right, to increment the counter. And of course we don't have this painter. Aha, okay. Now that makes more sense. So when we have this function, we explicitly expect this value, right? The counter that we're gonna be calling increment on to be an isolated counter. And now, if you invert everything that way, it makes a lot more sense. So essentially, the only way for us to be able to call counter is to take this counter and turn it into an isolated counter. Reading the error, we see receiver type is not a subtype of target type. Receiver type is counter ref, which is here, right? And counter ref is not a subtype of counter ISO. Ref is not a subcapability of ISO. So we would probably want to make create, also return an isolated counter. So if we compile, this should compile. I would have expected that to compile. What? Counter ISO bank. What do you mean? Seriously, what do you mean? Counter ISO is not a subtype of counter ISO. ISO bang is not a subcap of ISO. Alright, let's copy this. Keep it there. Cool. And let's continue with the tutorial. I guess the aliasing will have ephemeral types. Hmm. So how do you make it so that the constructor returns you something, right? That is of the type you're expecting. Sorry, that has the capabilities you're expecting. So there's something about being ephemeral here that I don't get. This will be possible if the subcap were more ephemeral. Okay, I'm confused about a way of creating values that have these capabilities. I'm not sure how to create a value that is ISO. I understand that if I define methods or behaviors to work with actors or objects are essentially are required to comply with a particular capability, like ISO, for example, then I'm guaranteed that this object is only accessed by a single thing in the whole of the program. So I wonder if I can, no, if I use tag, then, how will this work? Right. So if I get a transition object, then I can write to it. Oh, wait. If I get a tag object, and that means the instance of the counter that I got is a tag, which means I cannot access anything inside. If I get a transition object here, it just means I can't really read to it, right? If I get a ref object, then I should be able to modify this thing, which makes sense, right? Now, what I'm curious about is whether I can create values that have different capabilities or not, or whether I can just expect them to have some of them, such as, can I create a value that will be an ISO, or can I just expect a value to be an ISO? And then whenever I'm given a value, because I expected a value to be an ISO, it will be turned into one if it can be turned into it. That's the thing I have in my head right now. So for doing that, I'm actually gonna do a primitive called util counter utils, and it will have a function, and the function will essentially expect to get a reference. Actually, it will expect a counter ref, right? And it will return 128. And it has no, oh yeah, on the default implementation should be this one. Like that. Which sounds silly because we already have the method, right? I'm just trying to prove that if I create a value and I pass it through a function, then that's how I attach capabilities to it. Rather, I request capabilities, and by requesting the capability is how I will narrow down what I can do with the object or what I can't do with it. It's very likely that this is wrong though. So that worked, right? But if what I expect here is not it's a one of these transactionals, then I shouldn't be able to write it. Phone line capabilities. Let's see what we find out there. That's a tutorial I'm going through. Hmm. Right, so I'm gonna have to give this another shot. Okay. So there's 6 capabilities. The capabilities are essentially what restrict how you can use variables rather. So you can say let C value to be a counter value, right? Counter 2112. And this should compile, or at least. Then I don't really know what the ordering is between these things, right? So if this by default is give me a ref, then why can't I turn it into a val? So by default, this would be a ref, which I mean if I want to make it ISO, I have to turn it as an ISO up there. Huh, so that works. And if I want to get an ISO here, and an ISO here, so if I create a counter as an isolated variable, then I seem to be able to use it wherever I would need to use a reference. Okay, let's do something a little simpler. Let's play around with this as using these examples that we have on the left, right? So we'll do let ISO string, and this will be a string ISO, and it will be hello. Okay, so we can't do that. Great. Does this mean that I need to what? Nine, 5. Oh, right. The arrow. Okay, so that works. I have an ISO string. right? Which means I shouldn't be able to operate with it. Right, so I can turn it into a string value by returning the value that I have inside. But if I pass this around, then they're just not able to use it. Well, actually, print is not defined to be used, I guess. So if I have string utils, that's a print, like that, right? Primitives, string utils, and I guess like font, print ISO. This will get a string ISO. By default would be a ref. I can do to value. Right, so this is expecting a ref, but I can actually give it an ISO. I have to say this is very confusing. I find it very interesting, but I think it's because I can't understand it right now. Rather, I can't stand that I don't understand it. So I need to crack it, sort of. Writes are part of a capability. If you open a file in Unix and get a file descriptor back, that file descriptor is a token that designates an object, but it isn't a capability. It's not something that tells me what I can do with it or what I can't do with it. To be a capability, we need to open that file with some permission, some access right. For example, when you give it the file permission, then you get a capability back that lets you read and write from it. Okay. Importing every reference has both a type and a reference capability. In fact, the reference capability is part of the type, of its type. This allows you to specify which of your objects can be shared with other actors and allow the compiler to check that what you're doing is concurrency safe. Okay. So what he's saying here is that if I had an actor B, right? Or rather an actor printer. I don't know how to type lambdas to request them as parameters. Precisely. Okay, that makes more sense now. So it has to be an ISO, a val, or a tag. Okay, now I'm getting the gist of it. So I have this little class for counter. I'll make this a little smaller. And this is just a counter that can be incremented, and then you can get the value, right? It mutates in its internal state. So here it's 0, but here it's 1, right? And here we have the counter, which has like I equals 1. So right now this one will be a ref, which means we can't really modify the object itself. So if we started saying val here, right? When we create this thing, good enough. We need create. What changed? Okay, so if I make this a val, then that means capabilities work. which means this is not going to let me change it because it's a val, which means I need to expect here a ref at least, right? Cool. I think I'm getting a better idea of what's happening here. Oops. So when we create actor A, we create an actor B, and we create a counter C. The counter will be a value, which means we can't really modify what's inside it, right? So if we go to line 23, here it says counter ref. It's not a subtype of counter val. Ref is not a subtype of subcapability of val, which means that probably we want to tell it then to return a ref there. Okay, that doesn't work. So val really doesn't really cut it here. The counter itself may need to be a ref, at the very least a ref, to be able to be modified, right? So there's some interplay here between the capabilities that you need to change the data and the capabilities that you need to send data over to other actors that I feel make Pony interesting. As I was reading in some of the Hacker News posts, or rather comments that we saw over here. Where is it? I forget where the link is. Yes. It feels like the overhead, the cognitive overhead of keeping these things around or having this many kinds of capabilities is high. But I don't know. I don't have anyone else to measure that myself, right? And it's taking me a little longer than I would have liked it to understand what's going on and to be able to start using them. But I get the sense that there will be no message passing syntax, and rather instead there will be actor behavior invocation of sorts. So I create an actor and then I tell it, okay, behave in this way, right? And it will behave in that way, and so on. Which I guess it's valid. So print counter here is getting a counter, and you should probably just get a val, right? We don't want it to modify or to do anything with it. But I think that this is not going to work unless you do a ref here. Alternatively, you could just say we actually want a counter to be an ISO. And if you call increment on this counter, the counter has to be isolated. But if you call get, it's fine if it's just a reference. Yeah, we'll crack this. Just give it a second. So we create this thing. It would be very nice to have some sort of auto-completion or inspection of the types, including the capabilities, to be able to know, oh, this by default is this thing, and what is this looking forward to? And this is looking forward to this other thing, right? Like I know print counter is trying to get a counter as a value. So I don't know if I can cast it down to a value, right? So here. What I do know, if I remove that, and this over here. So this has to be ref at the very least. Otherwise we can't mutate it. This requires a counter val, and that means that the reference is not good enough. Huh. So I get it. I have a reference and I need to turn it into a value, but I don't seem to be able to create a new value with this. So how do I create something with different capabilities? Is that my mistake? Is my mistake thinking that I can have a class for string and I can make an ISO string, a transition string, and so on? So about accessing the values. Do I need a different class for this? This would be really stupid. No, actually, that's just my first impression, right? But there might be very good reasons for it. And I guess that if I was to say fun get, then I could expect. Oh, come on. Really? Also value here will actually be calling countable value. Sorry, counter value. And then the printer will just require you to get it countable. Right? Okay, so the print counter, because it's the behavior, needs to get a value that's countable. I mean, value or ISO or something else. I have a trait for countable so that you can pass in one or the other indistinctly. And counter value. All right. These returns are countable val. Function body isn't the return type. But it is. Interesting. Very, very interesting. I'm running out of time here. Energies as well. I think the capability system is quite interesting in the language. It's something that I would definitely want to spend more time working and playing around with, really trying to get what the limits of it are, what things it can express, what things it can't express. It was interesting to see already that having these two different actors, right? When I essentially remove the value qualifier, type qualifier for the countable trait, it will immediately tell me that the parameter that I'm trying to send essentially across actors is not of the right type qualifier. It should be ISO, val, or tag. Which if it was ISO, right, then I wonder if I could send it immediately afterwards to a different actor, or if that will be a problem. I don't know. Oops. Not sure. Something to play around with. Anyways, we've seen a lot of what Pony feels like to be written when defining actors and classes and trying to make classes be subtypable with traits and interfaces, and defining primitives that we can use for encapsulating functions that are similar but require no closure over them, no state, no this, and how we can also use primitives to do subtyping through the type aliasing mechanism that lets you do algebraic data types where you have disjunct unions such as ORs, where you have tuples for products, but also where you have, and I don't know the other name that this has, essentially this over here, where you can define, this is not product of traits, you can define a type alias that would essentially have a single element to be a combination of multiple traits or interfaces. I think this only applies to traits though. And you can apply those three things, right? The one that says one element is of multiple types, the one that says there will be multiple elements, the commas, right, the tuple, and also the or. So you could say named and then named or starvable. And this will be a tuple that has one element that is both, one element that is named, and one element that can be named or starvable. Which make for a very, very flexible type system. And we've seen how the capabilities qualifiers in the language for isolation, transition, reference, values, boxes, and tags help us a little bit. We haven't made big breakthroughs there yet, but a little bit we've seen how it makes us enforce certain, for the lack of a better word, capabilities on the values that we are trying to send to different actors, so that an actor can never get a value that will accidentally be written by the original actor that sent it. So that if you want to send a message to an actor, which you don't really do with a specific syntax, as you would do in Erlang, for example, or Elixir, and it's also not, apparently it's also not aliased with a method syntax, such as in Ruby, where each method call that you have is essentially sending a message. You will end up having method invocation instead, but it happens asynchronously, right? You will say, hey, this is the method invocation, and it at some point will be executed. I reckon there's an isomorphism in there somewhere between the two. I just haven't looked for it too keenly yet. But what I was saying is that the capability system forces you to say this value that I'm sending over to a different actor that will run concurrently and should be completely shared memory free will have the requirement that the value needs to be isolated or a value, right? Which means they can only be read, it's globally immutable, or a transition variable, which means anyone can read from it, but it will be this person that's only reading, which sort of removes the error cases or the error modes where two people are writing to the same place and you get corrupt data. Honestly, I'm really intrigued by the language. I want to keep playing around with it, but I have other things to do today. And at 7 p.m. we have the first live stream from for the illiterate programmer. I am really excited for it. So I want to rest a little bit, rest my brain a little, eat something as well, and be ready, prepared for tonight. Okay, so we're gonna call it a day today. I think I've learned more, or I've spent more time thinking about capabilities than the actor model in Pony. Maybe this stream should have been called Exploring Capabilities in Pony. But I think we learned something about the way Pony models actors as well, that I think is useful. Thank you so much for sticking around. And if you've liked what you've seen, please subscribe. There will be more events. You can take a look at them here. I'm making this a little smaller so you can read. The next one is today at 7 p.m. And in a few days, we have the second part of building a design system in ReasonML. And there will be a few more others, like continuing to dig through the garbage collector in Reason Native on a Camel. I'm going to be exploring native actors with the C++ actor framework. And then we're going to do a little bit of machine learning with Reason before we get to do the original object-oriented / actor model on Smalltalk through Faro. All of these are going to be really interesting, really exploratory. Expect a lot of fuck-ups, a lot of how does this work, a lot of learning. Hopefully you'll learn something from them as well. And if you liked what you do, feel free to follow me on Twitter every now and then in this thread that I have going here. I publish, hey, I'm going live now, and here's where you can find more material on the particular topics. All of the videos will be uploaded eventually to a YouTube channel, which you can also subscribe to if you want to get notifications on it. And in here, I try to split things into small playlists, so it's easier for you to digest some of the things. There's a big one for Reason on a Camel, and there's another two that are starting to grow very slowly. Right now, they just have a single video. So this has been Reasonable Coding, and I hope you liked it. Have a great day, and as always, stay reasonable. See ya.